I want to talk about this problem. You're conducting a study to see if the proportion of men over the age of 50 who regularly have their prostate examined. A random sample of 704 men over the age of 50 found that 201 get examined. Do the sample data provide convincing evidence to support the claim? Test the relevant hypothesis testing using a 5% level of significance. Give the answer to at least 30 or to at least 4 decimal places. So here, P is greater than or equal to 0.31. We want to see if it's less than, right? So that's why we've got less than here. That looks good. This could be 0.31 here also. I guess the computer let you get away with 0.3. Well, that's fine, but it should be 0.31. Let's go ahead and go on. We want to find the test statistic, the critical value. Along the way, we'll also show you where that p-value comes from, the probability, right? So we're going to use these values here. We have 21 successes, 21 people get examined. So I'm in my Google Sheets, right? If you go down to the bottom, you have lots of different options for Google Sheets. And I'm going to go up to here. The hypothesis test for one proportion is one we want to use. Notice I've scrolled over to the right a little bit, right? So I'm going to go ahead and X is the number of successes, so there are 201. The number of people in my sample is 704, right? And it automatically figures out what my p hat is. All this is dividing these two numbers, right? The null proportion is 0.31 because that's what the null hypothesis is. So we go ahead and hit enter. And it tells me I've got my test statistic and I've got my two p-values. So it's a left-tailed test. I know it's left-tailed because this is a less than sign. So this value is the p-value I care about, this 0.08. So first, 0.08 is bigger than the alpha that we're going to use, so we're going to fail to reject. Right? We're going to say that this proportion, about 31% of men do get their prostate examined. That's fine. Even though in our sample we got about 29%, it's close enough to 31 to be fine. So so my test statistic is, what is it? I would call it negative. It would be here, negative 1.045. I would round it there. It says at least 4 decimal places. So I guess we have to go out to 9, right? So we'd have to type in 1.0449, like that. And it's got to be negative too, because it is a left test. So I got to have a negative there. The critical value, how do we find that? So if we go back over here, the critical value is just a z-score. And I will use this inverse normal to find it, right? The 0.05, the alpha, is going to tell us what our critical value is. So I'm going to make the area to the left of some number 0.05, and I'll point that out on this graph down here. The mean for a standard deviation, the mean is 0 and the standard deviation is 1 because we're in the standard normal. So our critical value is this number, and that's what you have there. If we scroll down, right, the critical value, what does it say? What do we got to do? Shade the sampling distribution curve with the critical values and shade the critical regions. The areas can only be jagged. Z-score is accurate to one place. So here is you've correctly identified your critical value, right? Notice that this area, this blue area here is 5%. That's what this represents. This is 5% of the area underneath the curve. The test statistic, this is not what the problem wants us to do, but the test statistic, if we move this over, boop, boop, right there, this area here is larger than 5%, right? So what is it? If we go here, this area turned out to be 8%. That's what the probability less than. And so really what we're doing when we're doing this hypothesis test is we're saying two things. Is the area for our test statistic bigger than the area for our critical value? If it is, then we will fail to reject. Or is our test statistic outside of our critical region, right? This is our critical region here, and our test statistic is outside of it because it's like over here, right? It's at negative 1.4. But anyway, that's how we use our Google Calculator to do this problem. Once again, our p-value that we would care about is this one, the left tail, because this less than sign here. If it had been, say the problem had been like not equal to, then it would be the two-tailed test here, right? All right. I hope that helps clear up how we use the Google Sheets calculator to find the critical value, to find the p-value, and to find the test statistic. All right, thanks.